according to low-strain reflected wave method. This pile dynamic detector is mainly composed of the host, the receiving sensor, hammer, and other fittings. It is very convenient to use hand or touch pen to operate in the touch screen directly. You can operate the machine through touch screen and keyboard area. On the left side of the host lies the channel 1 and channel 2, which can be connected by sensor. Next to the channel 1 are charging indicator and power switch. Open the protective cover under the host. You can see the round charging port. Next to charging port are two mini USB interfaces, which are used for PC connection to transfer data files. USB port is on the right side of the mini USB interfaces, and it is a standard USB port into which the flash disk could be inserted to copy the detection data file inside the instrument to flash disk, and then transfer to computer so that you can use the Windows Platform Analysis software for further processing. It can also be used to update internal software of the instrument. Protective cover will be closed when not in use so as to protect the above interfaces. Receiving sensor is connected direct with the detected pile to collect test signals. We use a hammer to strike the top of the pile to produce a stress wave. We provide to use several hammerheads of different widths and materials. The stress wave frequency caused by the striking of aluminum alloy hammer is pretty high, which is suitable to judge the shallow floor of the pile, while the stress wave frequency caused by the striking of nylon hammer is rather low, which is suitable to judge pile's deep defects. Besides, you can choose another force stick as striking device if the pile you test is too long and big. Instructions: we should do some preparations before testing. Clean the pile head. The coupling point of the sensor and the striking point of the hammer must be clean, flat, and hard. So it is necessary to do something with the pile head before testing. Clean the floating cement and other sundries on the pile head. Coupling agent should be thin but with great viscosity, and this viscosity should not be affected by water. We use butter here. Connect one end of the signal line of the sensor with the jack of the sensor on the left side of the instrument. Please mind a hump on the plug of the signal line and a groove in the jack, and aim the hump to the groove on connecting. When pulling the plug, you should pull it out gradually with holding the knurling part of the plug. Parameter settings. Turn on the instrument, click Starting Testing button and enter Main Software Interface. The interface consists of the following 5 sections: Waveform section, Pile chart and analysis parameter section, Function button section, Piles information section, and Cursors parameter section. Click the Setting button or press the Setup button on the right keyboard area and enter Parameter Setting interface. Create a new site and name it, and then create a new pile and name it. You can also only create a new pile in an existing site. You should input pile length and wave velocity as accurately as possible according to the actual situation, which will be helpful for the analysis of pile integrity. Click a Pile Info button, set the information of a pile's shape, diameter, and type. Test date and test time cannot be modified. As for new pile, the test date and time is the system date and time. As for the measured pile, it is the date and time when it was tested. Click Advanced button, and advanced parameters for sampling could be set here. Sampling interval is the time difference between every two sampling signals. This value can be set or not, but pile length and velocity must be set as accurately as possible before sampling so that it will automatically calculate the sampling interval value. Blue number refers to the total number waveform that every channel to collect. There are multiple options. Minimum is 1 and maximum is 12. Gain is the amplification of the electrical signal received by sensor of the instrument. Its designated fixed magnification 1, 2, 5, 10, 20, 50, and 100 can be chosen, and generally it is set to 10. When the signal is so weak that it is not easy to trigger, increase the gain value. When the signal is too strong, decrease the gain value. Trigger level is the level of a signal collected when starting the instrument, and there are 3 levels: low, medium, and high. Higher the set is, stronger the receiving signal be required. Generally, in pile testing, it better choose low level when the gain value is less than 10, and it better choose medium or high level when the gain value is more than 10. Overlap. You can choose a number between 1 and 6. If the number is bigger than 1, it is an overlapping sample, which means all the samples collected in the same channel will be added together and averaged. As for sensor, acceleration sensor and speed sensor can be chosen. The standard sensor is ICP accelerometer. Sampling points is the quantity of signal sampling points, and usually it is set to 1, 0 to 4. Screen refers to the amount of waveform displayed in every screen. Options is 1, 2, 3, or 4. Number in every panel cannot be bigger than the sampling number. Sampling channel. The dynamic detector has 2 receiving channels in all. When testing, we can choose channel 1 or channel 2 for collection or both. Choose the channel in which the sensor is, or you will fail to collect signals. If you choose dual channel 1, double channel sampling is adopted, and the triggering channel is channel 1. If you choose dual channel 2, double channel sampling is adopted, and the triggering channel is channel 2. Acceptance mode. 3 modes are accepted: automatic, manual, and all. In automatic mode, if the strike is too heavy or light, the dynamic detector will automatically abandon the signal while show corresponding message. Only when the percussion is moderate will the collected signal to be a useful one. In manual mode, if the strike is too heavy or light, dynamic detector will give an appropriate message and ask whether to retain the signal or not. When the all mode be selected, if the strike is too heavy or light, dynamic detector will be given the corresponding message and keep the signal. X-axis can be length or time, and generally we choose length. Pile test. You can choose 1 to 4 testing points according to how big the pile is. Defects or cracks are not allowed at the installation point of the sensor or somewhere near it. When the hammering point is at the center of the pile head, the distance between the installation point of the sensor and the center of the pile should be 2/3 of the pile radius. When the hammering point is not at the center of the pile head, the distance between the installation point of the sensor and the striking point should be more than a half of the pile radius. Take a 1 meter diameter pile as an example. We choose 3 testing points and locate a hammering point at the center of the pile. Sensor should be completely stuck to the pile head by butter or petroleum, and ensure the sensor is vertical to the top of pile. Click on Sample button, strike the center of the pile 3 times with the hammer, and then click on Stop button. Then place the sensor at the second testing point. Click on Sample button, strike the center of the pile 3 times with the hammer, and then click on Stop button. At last, place the sensor at the third testing point, and striking the center of the pile 3 times with the hammer again, and then click on Stop button. Click on Save button after you have finished the sampling work. The default name is the pile name set before the test, and you can save directly if you don't need to change it. Then we finish the test of the pile. If you need to continue to test other piles, click button New Pile in the pile information area, then you can continue to detect the next pile. After you have tested all the piles, data files can be transferred to your computer for analysis and report generation. Copy the data files. Insert the USB flash disk into the USB port of the instrument, and then turn down the power switch. Click Starting Testing button. You can enter the main software interface. Click File button to enter the File Management interface and choose the project to be copied, and then click Copy, copying all files of the selected project into the USB flash disk. Data Analysis. Click and open Analytics software of testing pile by reflected wave. Click File button and find the file you want to analyze and open it. The middle part of the software interface is Wave Diagram area. Pile list of this project lines on the left side of Wave Diagram area. Pile Information area and Waveform Processing area line above Wave Diagram area. You can further improve or modify the pile's information in Pile Information area on the left side. Look at Waveform Processing area on the right side. You should choose Integral, as we use ICP acceleration sensor. Wavelet factor can optimize the signal through wavelet analysis method. And the bigger the wavelet factor is, the smoother the signal diagram is. Generally, wavelet factor should be set between 1 and 3, but you can set a bigger wavelet factor if the pile you detect is pretty long. If the wavelet factor you set is too big, some useful signals will be filtered out, causing misjudgment. Smoothing points refers to how smooth the signal diagram is. The bigger the smoothing points is, the smoother the signal diagram is. Smoothing points range between 3 and 512, and generally it is set at 10. Amplification type, you have 3 kinds of choice: exponent, linear, and full scale. Usually, we select exponent. Its characteristic is the signal will be magnified on exponent. As for amplification factor, you can choose according to your need. Amplification from means the starting place to magnify. Filtering mode has 4 types: all pass, low pass, high pass, and band pass. Low pass can filter out the signals higher than a certain cutoff frequency. High pass can filter out the signals lower than a certain cutoff frequency. Band pass can filter out the signals higher than a certain cutoff frequency and at the same time lower than a certain cutoff frequency. Usually, we choose low pass more. Waveform rotation. Sometimes after the integral processing of the signal, the end of waveform will be obtained. Then the waveform needs to rotate, making the end back to the position of the baseline. The percentage of the rotation is relative to the amplitude of direct wave. Positive number indicate clockwise rotation, while negative number indicate counterclockwise rotation. Default means user set all parameters as the recent one. Parameter recovery means user set the parameters value as the default one. Tension and compression ratio means users can compress and stretch the waveform. Now, we will analyze several typical waveforms. Good pile waveform. As the waveform from a good pile, wave crest will appear separately at pile head and pile toe. And if pile body hasn't defects, the waveform diagram between the pile head and pile toe will be a straight line. Double-clicking on the waveform area stretches the waveform vertically. Expanded pile waveform. This is a 45-meter pile, and the first wave crest is the pile head, and you can find another wave crest at a pile toe, but a significant wave trough appears at about 5 meters. This is a typical waveform of expanded pile. Reduced pile waveform. Except for the wave crest at pile head and pile toe, another wave crest appears, caused by secondary reflection of a reduced pile. This is the typical reduced pile waveform. Broken pile waveform. In this waveform, the first wave crest is pile head. This pile is 10 meters, so the pile toe wave crest is supposed to appear at 10 meters, but it doesn't. You can see a wave crest appears at about 3.5 meters, and you can also find other wave crests every 3.5 meters. This is the typical waveform characteristic of a broken pile. Create a report. When you create a report, choose the IT files on the pile list area.